Okay, this video is going to be a quick review of ionic bonding so that we can jump into some more complicated problems having to do with ionic bonding. So first, how do we find ionic charge? When we're looking at the periodic table, all atoms want to have valence electrons. So if you remember, we count columns 1 and 2, we skip over all of those middle elements, and then we count columns 13 through 18, and that gives us a potential total of 8 valence electrons. Okay, all atoms want to have 8 regardless of how many they start with. Atoms are lazy. They will always take the easier route to get to 8 electrons. So for example, if an atom starts with 2 valence electrons, it's easier for them to lose that 2 electrons than to try to gain 6. Okay, so our benchmarks are kind of 8 and 0. Now with hydrogen's trying to get to 2. Okay, the only exception there are when we're at hydrogen. Hydrogen's row only has 2 elements in it. It wants to be like helium. It either gains one to be like helium or it loses the one it already started with to go down to a complete 0 electrons. Electrons are negatively charged, which means that losing an electron leaves the atom positively charged. Nonmetals form negative charges and metals form positive charges. So an example here, what is the charge of nitrogen? Nitrogen starts with 5 valence electrons. It's easier to gain 3 up to 8 than it is to lose 5 down to 0. So gaining 3 electrons equals that -3 charge, right? We're gaining 3 negative things. So we would write that as N with a -3. Ions bond in ratios to form a neutral compound. So we need our positives to add up to equal our negatives so that overall we have a neutral or 0 overall charge. Okay, our overall charge must add up to be 0 or neutral. We use subscripts to show how many of each type of ion are needed to balance out the charges. Okay, so an example here. I have calcium, which has a +2 charge. I have oxygen, which has a -2. My +2 and my -2 equals 0. So there's one of each ion needed for an overall charge of 0. So my formula then would be CaO. Notice I don't put the 1 subscripts. They just aren't needed. Okay, kind of like in math when we write X, we don't need to always say 1X. To name compounds, we use the periodic table. Okay, we have a cation, the positive. The name stays the same, exactly the same as it is off the periodic table. With the anion, the negative things, the name is off the periodic table with the ending changed to "ide." And remember, there's not a real good rule for how much of that ending changes to "ide, so do your best with that. My kind of tip is if you say it out loud and it sounds funny, it's probably wrong. Okay, oxygen sounds really funny, but oxide sounds pretty normal. Our example here, Na2O. Na is sodium, O is oxygen. We change that to oxide, and so our name of Na2O is sodium oxide. Notice that there are no prefixes here. Okay, I would figure out this 2 subscript by figuring out the charge on sodium, the charge on oxygen, and then figuring out how to balance that. Okay, we do not write prefixes in ionic naming. Now, some practice. I want you to try these on your own and then play for the answers and explanations. So when I show these on here, you are going to pause your video. You're going to give them an attempt and then play it again for me to go through them. So our first one, what is the name of Ca3N2? What is the formula for sodium iodide? What is the name of a compound made from magnesium and chlorine? And what is the formula for potassium nitride? Okay, I want you to pause. When you're done with all of these, hit play again, and I will talk you through these. Okay, so here's how we're going through these. Okay, we've got the name of Ca3N. Calcium, Ca is calcium, N is nitrogen. We change that to nitride. We get calcium nitride. No prefixes for the 3 or the 2. Formula for sodium iodide. We have sodium, which is an Na+1. We have iodide, which is really iodine. it's I with a negative 1. So our plus 1 and our minus 1, they balance each other out to get NaI. Name of a compound made from magnesium and chlorine. Magnesium is our positive metal, so it stays the same. Chlorine's name changes to chloride, which makes our name magnesium chloride. And finally, what is the formula for potassium nitride? Potassium is a K plus 1. Nitride is nitrogen, which is an N minus 3. We have K plus 1, N minus 3. We need 3 of these Ks to balance out that negative 3 on the N, so I get K3N. Okay, hopefully this was a quick refresher of what we did in matter G. Go ahead and start working through matter matter H, which is going to take you through how to name with more complicated scenarios. If you have any questions, make sure you ask your teacher.